Okay, Math 100, 822. I was thinking about what to do in class today, and in my college algebra class, we actually did, part of what we did today was what you see on these worksheets. Let's look at these worksheets, or the worksheet I gave you. Problem 1 says graph 2y equals 6x plus 4. Let me replace that problem, because some of you already worked this one. Let me see if I can just come up with another problem on the fly here. What would be a good problem? How about 3y equals 2x, what do you think, minus 1? That look good? So the instructions are graph this. So, and the reason we're going over this is it's on the final. And it'll probably be on a test before that. Okay, so points is points. You might as well get the easy ones. What do we do first here? Yeah, you have to solve for y. Get it by itself. So what we're going to do here. Divide everything here by 3. So y equals 2/3 x minus 1/3. And to do this, we divide it by 3. Okay? That's how we got from 3y equals 2x minus 1 to y equals 2/3 x minus 3. Now, what comes next? If I say graph this, what are you going to do next? Act like you don't know anything about the calculator. What do you do next? Yeah, you need a table of values, don't you? You need something that looks like this, x and y. Y'all remember that? Sometimes it could be x and y, like that. Same difference. Here's what I do. Draw the x and y. I come out there and put a 0 in immediately. You always want to check the point x equals 0. That would be the y-intercept, wouldn't it? So, when x is 0, what is y? Negative 1/3. Now what? We need some more values, don't we? We need to pick some x values and find out what y is. Anybody have any ideas?
1, 2, -1, -2.
Well, how about we do this? Watch. Look at this. There's a 3 there, isn't there? If you do this, if you say, okay, I'm going to go x equals 3 and x equals -3, maybe that makes your life easier. Because if x equals 3, you're going to have 2/3 of 3 minus 1/3. So what's 2/3 times 3?
2.
Be 2. And then minus 1/3 is 5/3. Now go with x equals -3. What's 2/3 of -3? -2 minus 1/3. So -2 is 6/3, isn't it? So minus another third, you're going to have a minus 7/3. Now, the reason I picked that and that is it cancels the 2/3, and that makes the filling out the table, I think, a little easier. Now we could have picked x equals 1, and in this case it wouldn't have been that much different, but there's a lot of times I actually do think it makes a difference if you pick out x values to match the denominator of your fraction. Life gets simpler. Now, instructions are graph this. Alright, let's graph this. There's nothing really extreme about our values here, are there? So we can draw our x-axis right in the middle. So anywhere convenient here. Same thing with the y values, nothing unusual there. So this is the y-axis. So let's see, let's start here with x equals -3. Oh, one more thing you should do here after you label your axis. You should make up your mind what your scale is going to be. So in this case, I'm just going to let each square be 1 unit. So 2, 4, that'll be x equals 5, 2, 4. This will be y equals 5. Now we can plot our points. But x equals -3, y equals negative 7 thirds. So x equals -3 is out here. And then the negative 7 thirds is actually, what, 2 1/3? Negative 2 1/3, which puts us right about there. And the point x equals 0, y equals a negative 1/3 was right there. Sometimes it works better if I do this. Change the colors on these. So -3, negative 7 thirds is, dank on it. Push the wrong button. 3, negative 7 thirds is there. 0, -3 is there. 3, 5 thirds is not quite 2, is it? Now we need to see if that's a straight line. And within the limitations of my ability to get a straight line on this paper, I think we're okay. So, believe it or not, we really ask you this on the test and the final. Okay, I know it seems like busy work, but let's check this with the calculator. How many people got their calculators? Most everybody got a calculator? Y'all got yours? Some people, there's actually one that you can get on the phone. I think it's kind of unhandy to use, but you can scoot over and show them how to do it. Here's the way we could do this on the calculator. We still have to do this. We still have to get it in that form, which is actually the slope-intercept form. But on our calculators, we can do this. Notice right here it says y equals. Press that. And I'm going to clear out that particular function right there. I'm going to enter this in right here. So see, there's my y. And notice I can put in, I think there's 8 of these I can put in at once. To get to 2/3, I'm going to put that in parentheses. So open up parentheses. Matter of fact, I use parentheses a lot. Okay? Parentheses, the use of parentheses forces the calculator to do the operations in the order that you want. Now there is a default order. I guess because I can't remember what that is, I just put in a lot of parentheses. Okay? So I opened up parentheses there, and I'm going to do 2 divided by 3, close that parentheses. So that's the 2/3 right there. The X comes from right here, this button right here. And when you push this, if you don't get an X, your calculator is in the wrong mode. And bring it up to me, and I'll switch modes for you. Okay? And then we need a minus 1/3. Now, this minus here, it's not the leading minus, so we use this one right here. Minus. And again, I put this in parentheses just to make sure the calculator doesn't misinterpret what I wanted it to do. So the only thing I did there was I put in y equals 2/3 x minus 1/3. I put this in. And now I can click on, I'm going to go to my zoom. I'm going to do zoom standard because I think mine remembered where I was a while ago. Ordinarily, you would go just to do this. You'd say zoom, or you do, oh, wait a minute. Don't worry about that. Just hit the graph, and you're going to get that. I had to go to zoom and change my window back to the standard default because I remembered I had something different in a while ago. Your calculator, remember the last thing you did. My calculator here, if I turn it off and turn it back on, it will forget my settings. Yours will remember. Okay? Now, can we tell anything about that? Does that look like this? Well, maybe, but it's hard to tell since it crosses the axis at 0 and -3. It's kind of hard to tell, isn't it? Let's change our window. So I'm going to click here on window. This is the standard window. X goes from minus 10 to positive 10, and Y goes from -10 to positive 10. Let's change that. Let's change this to 5, and I want to get rid of that 0. And notice I didn't hit clear because that would have wiped out everything. I hit the delete. Delete deletes a single character. Clear everything. Watch. If I come down here to X max and hit clear, it's all gone. So I want to go -5 to +5. And the same thing here for Y min and Y max. Now watch this. Everybody pay attention here. This is something that'll trip you up from time to time. I want to clear this. Clear. And I want to go back with -5. But I can't use this negative sign right there. Everybody see where I'm at over on the right hand side? I can't use that one because it's the leading. I want a leading negative. So for that one case, if you need a negative sign out in the front of anything, you go to this negative sign down here that's right to the left of the enter key. I usually call it the negation key. So that negative and then a -5, and the max here, I'm going to go 5. And I'm okay with that. Now hit graph again. Now we can see more detail, can't we? And it looks like for sure that the graph, the y-intercept here is 0 and -1/3. Okay, so sometimes you've got to adjust your window to see more detail. Okay? Now, we did this the hard way, didn't we? Those of you who've had any experience with a graphing calculator know that the calculator will do this right here for you. And here's where you find it at. Now, I already put my function in here as y1. Now, if I go over here and click the second key, that'll get me to these features that are above these blue keys. The one over on the right says table. So click that. And notice I got a table here. Now I've been fooling with my table settings, and I'm actually counting here by 12s. Okay? -12, 0, +12. If you don't like what it's, the increments, go to second, table set. So I'm going to tell my table to start at 0 and step this delta table That's what the little thing looks like a triangle. Is actually the Greek letter delta, which we use to indicate a difference. So delta table is the same thing as a step value. I'm going to do a 1 there. And now I hit second table. So now we start at 0, and we're going up by 1. We want to go backwards. We hit the up and down arrows. And let's see, we had -3. We decided that was minus 7/3, which would be 2 1/3. So yep, -2 1/3. And then x equals 0, -1/3. And x equals 3 would be 5/3, which is 1.667. You know, to ever how many decimal places you want to go. So once you put this in here, you can go to the table and find out all these nice values without having to do any work. Okay? You will use this calculator extensively this semester. It will be your friend. Seriously, it will. Okay? And since we're talking about the table, what if I said, well, I wonder what y is when x equals 27? So I'm saying x equals 27, I wonder what y is. Well, we could plug in 27 into our original function, or we could just scroll up looking for x equals 27. Now that's going to take a while, isn't it? But we can go back to table set, and now instead of the table starting at 5 in this case, we can just say 27. And do second table again. And now instead of me having to scroll up all the way, it goes right up to 27. So let's see, when x equals 27, y equals, looks like 17 2/3. That was pretty easy, wasn't it? Now let me throw something else out here. So far I've been giving you x values and use the calculator to give me a y value. What if we said this? What if we said, what's the x value that corresponds to y equal to 50? Now, we could plug this in. We really could. We could plug this in right up here and then subtract that, divide by 2/3. Boy, that's going to be messy, isn't it? Watch what the calculator do for you. All right. Go over here to y equals. Leave that in there. Scroll down and put y2 equals 50. Okay? Now, the problem is here, we've got to be able to see what happens here in our window. Right now, if we hit graph, that's our original function. I don't see anything else that's changed, have I? Because remember, this only went up to 5. And I just got through saying, well, what happens when y equals 50? Y equals 50 is way on up there, isn't it? I have to change my window. Now, if you're sitting there thinking, I don't know what to change my window to. Well, look, let's go check out the table. Okay, here's my y values. If I just scroll on down, watching here, and this would be a good place to use delta table and jump on up. But let's see here. Y is 42, 43, 45, 47, 49, 50. All right, looks like somewhere between x equals 75 and x equals 76, it crosses from 49 to 50. All right, that tells me what my window needs to be. So watch, I'm going to change my window. Remember, it happens between 75 and 76 for x. All right, so window. I'm okay leaving the minimum at -5. Here we need at least 75. Let's go 80. And I'm going to change the scale to 10 because otherwise it puts a lot of little tick marks on there and it's kind of muddies up your axis. I'm okay with leaving y min at -5. And this has to be at least 50, doesn't it? I usually go a little past this. Let's go 60 on this. And again, I'm going to change the scale to 10. Now hit graph. So there's our original line. And there's another line. Where do you think this one came from? We know where this one came from. What about that one? Where does it come from? Yeah, that's y2. Y equals 50. Y equals 50 is a straight line. It's a straight horizontal line. For every value of x, y is still 50. So you get a straight line. And now watch what happens. The calculator has a feature that will find the intersection of these 2 points. These 2 lines, rather. There is one point where these cross. So, second, see where it says calc? There's some pretty neat stuff under calc. So it's second calc. Come down to intersection. Press enter. Now, it's going to ask you for the 2 curves, and a line, a straight line is still mathematically considered to be a curve. Although it's straight, it's still a curve. So all lines are curves, all curves are not lines. Okay? So, first curve, you notice a little blinking cursor there? Right there. So this is our original function. So you press enter, we want that one. And then it switches up here to y2 equals 50. That's the other line. Press enter. Now whoever wrote the program for this calculator, and by the way, a programmer sat down and wrote, or probably a team of programmers, wrote everything that's in this calculator. Okay? So whoever wrote this put in asking for a guess. Now I don't know why, and I don't guess. I want to know the answer. Point is, you have to hit enter again. So you hit enter again, and it tells you, oh, the intersection. So it turns out that if you want y equals 50, which we do, that happens when x equals 75.5. So that's 75.5. So we use the calculator to find the answer to that. And that would be a lot handier than doing what? Plugging in there and doing that by hand. That's pretty cool, isn't it? We will use this idea a lot. Graph a straight line and see where it intersects the function that we're working on. Okay. Let's see what else we have here. That was an amended problem 1, wasn't it? Y'all work on number 3. We didn't get to number 3 in the college algebra. Work on number 3. Now, what's the first thing you got to do here? So I give you 5x plus 2y equals 20. Can you put that in the calculator like that? No, we got to do something first, don't we? We have to do a little algebra. Sorry about that. So what are you going to do? 2y equals what? Okay, now what? So what y'all got? So first we subtract 5x. And I can't say subtract negative 5x because that'd be actually adding it, wouldn't it? Subtract 5x, divide by 10. Now, this is a form you can actually put in your calculator, so do that. And get yourself some nice values there that you can use to graph. Let me give you a little hint. Notice we've got a negative 5 halves. This is one of those cases where we have to use this little negative sign down here.
be divided by 2
What? Where?
on the side written.
Oh, okay. I'll fix that. Divide by, you're right. Divide by 2. And you get 10. Now, notice here we've got this negative sign right here. Here's what we got to do. And I do it like this. Hit this little negative sign down here at the bottom beside, to the left of the enter key. And if you watch carefully, it is actually above the center line. Watch. If I do this, that's the regular negative or subtraction sign. See the difference? Okay? So in this case, since that's a leading negative, we want to use the one down here to the left of the enter key. So now I'm going to do, in parentheses, 5 divided by 2, close parentheses, x plus 10. So if your negative sign is out in front, you've got to use the other one. Okay? And I'm going to have to fix my window, aren't I? Zoom standard gives you the 10 by 10. So how would we find some nice values here to make a graph if we want to do this by hand? Remember? Second table. Now, I don't know where my table's at. It's on 71. Gosh. So, second table set. Let's just take it back down to 0. And now let's look at the table again. Alright. Let's see. When x equals 0, y equals 10. We sure want that point, wouldn't we? And I usually try to get a negative. So here's the points I'd pick out. So that'd be 10, and then a negative 2 is a positive 15, and 2 would be a 5. And if I were doing this by hand, I would have picked the 2, negative 2 and the 2 anyway, because of this. This number and this number cancels that out. So you get rid of your fractions. So certainly, if you have the choice, pick values for x that get rid of those nasty little fractions. And while we're thinking about it, what if I said, well, where's y equal, we can actually do this. What if I said, where's y equal to 0? By the way, this is a fancy way of saying the x intercept. And this is the y intercept. Anybody have any ideas there? Would be a quick way of coming up with the x-intercept? Well, actually, in this case, you can read it right off there. But let me show you the other way. Well, what did we do before? Let's graph a straight line. In this case, y equals 0. Now, y equals 0 is actually the x-axis. So you can't see the line, but it's there. So when I graph it, you can't see it, but it's there. Second calc. Oops. Second calc. I didn't hit the second key hard enough. Intercept. Press enter. First curve is actually our straight line function there. And the blinking cursor is right up there. If you can't see it, you can move it with the left and right arrow key. See how I'm moving it to the right? So that's my first curve. Press enter. Notice the second curve comes down here on the x-axis. because that's where y equals 0, isn't it? So that's what I want. Press enter. I don't care about a guess. So when y equals 0, x equals 4. That's pretty cool, isn't it? So throughout the class, sometimes I'll give you, and this happens in college algebra, I'll give you an x, you find y. And for the most part, use the table. Or I'll give you a y, you find what? An x. And to do that, do an intersection, which means, of course, you have to graph, you have to add a line, and to do the intersection. You should really remember these, because this comes up all the time. Okay? I'm giving away all the secrets to the class on like the first couple of weeks. And if y'all believe me, we'll cruise right through this. All right? Okay. Any questions? What? Only a little? Well, you're doing good then. What do you need? What?
I'm not sure. I don't know. I just don't understand it, kind of. I do, but then I don't.
Well, here, listen to this, Robin. You'll like this. I actually tell my students that confusion is a good thing. Because before you learn anything about something, you're not confused at all, are you? You know nothing about it, but you're not confused at all. But when you start learning about something, but it hasn't quite come together yet, you're confused. But you've actually learned stuff. So if you're not confused, you either know it absolutely or you have no clue and don't even know that you don't know what you don't know. Tell you what, it takes me a while sometimes. What I do is I turn these into videos. Watch the video. I put a link to the video on Blackboard or in Blackboard. You can click it and watch this all over again. And then Wednesday, you say, hey, this is what I don't understand. Okay? So this class, this 100 class, I'm just trying to get y'all through 150. So if you come in here and say, I don't understand this, we'll spend as much time as it takes working on whatever you don't understand. Okay? Because if you don't understand it, there's probably some other people that don't understand it either. Sometimes they don't know what they don't know. Okay? All right. See y'all Wednesday.
Do we need to do the rest of these?
Yeah, you work on the rest of these between now and Wednesday. We'll go over them Wednesday. Practice, practice, practice.